make a video that is potentially useful as opposed to me rambling about my opinions on what should be taught about inverse function. Okay. So you did number 1 and number 2. Or not. Do you want to start on number 2?
Let's start on number 2.
Okay. So it's C equals F of A. Right? C is the cost of building a store of area A. Right? Explain in terms of cost in square feet what the following quantities represent. So F of 10,000 you tell me.
It would be the cost when the area is 1,000 feet.
Well, 10,000, yeah.
10,000.
Right. I mean, yes, I agree. Cost of 10,000. What's that? 10 to the 4th. Okay. So this is like checking for a pulse.
Yeah.
F inverse of 20,000.
Would it would be the area is 20,000 feet now.
Be careful. The input, so F takes area and outputs dollars, which means F inverse takes dollars and outputs area.
Okay.
This is on one level just purely mechanical. We swap domain and range for inverse functions. That is one reason to, like, the idea of graphing inverse functions on the same axis as the original function, as is suggested by the method of reflect across the line y equals x, totally obliterates this notion of swapping domain and range. Right? Because if my graph is let's zoom out. If I'm graphing area versus cost, right, and presumably my function goes up, right? If I want to graph the inverse function, I don't do this, because now the inverse function as graphed would indicate that it would take area as an argument and output cost, and it doesn't.
Okay.
Right? The inverse function is, you're better off thinking about the inverse function as like, take this thing and do this. Okay? Yeah, I mean, because when I have an inverse function, it's messed up because now these are the positive and these are the negative. But like, the inverse takes as its argument cost, right, and outputs area. So the inverse needs to be graphed on not these axes. That makes sense?
Yeah.
So Anyway, mechanically, though, if we just tell ourselves what the domain and the range are of the inverse function, we know that this number has to be a cost, and this number has to be an area.
Yeah.
Right? So, an interpretation of this notion would be like, okay, this is how much store you can buy for $20,000.
Okay.
Right? If you have $20,000, this is what you can buy.
I see.
Okay? So yeah, I endorse the mechanics of switching domain and range. That is what you do when you swap y and x.
Yeah.
And solve for y.
Right.
Right. Okay. Number 3. Number 3 says f of x equals temperature. So I'll write degrees Fahrenheit. When the column of mercury is x inches long, f of x is f when mercury, I should use Hg for mercury. Aren't you taking chemistry?
Biology. I stayed in it.
So you are taking biology?
Yeah.
Did you not have a choice, or?
It was either going with chemistry and having a horrible teacher, or staying with the really good teacher in biology. So.
Horrible subject. When Hg is x inches. Okay. So the question is, what is F inverse of 75 degrees? Again, the domain here is inches.
Right. So it would be the height of Mercury at 75 degrees.
Yeah, as soon as you force yourself to make the switch, it becomes kind of a silly question, actually, right? I mean, okay. Blah. So, problems 4 through 7 decide whether the function f is invertible. The answer is yes. They are invertible. The question is just the domain, but that's not the spirit of which they're asking the question. So, f of t is customers at a store at time t. So I'm cutting through a lot of gibberish in the question. Invertible or not? So, answering this question conceptually amounts to answering the question, can customers be equal when times are different?
Yes.
Okay. Abstractly, so yeah, it's clear in this example, the answer is yes, which means the answer to the question of is it invertible is no. Right? The reason why x squared is not invertible is because f of 2 is the 4, but so is f of negative 2, which
Right.
means we have the same number of customers, but at different times.
Right.
Okay.
Mm-hmm.
Hopefully now, like, this is clarifying
Yeah.
in your head, and there's kind of no way to do it other than, like, you talk about it, and then you look back on your previous self, and you're like, why didn't I get this?
Uh-huh.
You know? So...